Good morning. In today's session, we will take some problems based on moving charges in a magnetic field. Take down the first one. An electron and a proton moving the same speed enter the same magnetic field at right angles to the direction of magnetic field. At right angles to the direction of the magnetic field. For which of the two particles will the radius of circular path be smaller? Will the radius of circular path be smaller? Let us read the question once again. An electron and a proton moving with the same speed enter the same magnetic field at right angles to the direction of the magnetic field. For which of the two particles will the radius of circular path be smaller? Now we know that when a moving charge enters the magnetic field in such a way that the velocity is perpendicular to the direction of the magnetic field, that means this part, the charge enter the field at right angles to the direction of the magnetic field. In this case, the charge follows a circular path, and the radius of the circular path is given by radius of the circular path in the magnetic field as given by R is equal to mv by qb. Here m is the mass of the charge, v is the velocity of the charge, q is the charge, and b is the field. Now it is given that the electron and proton, the same speed enter the same magnetic field. Here velocity is same, b is also same. So being the same speed and the same magnetic field for electron and proton, we can write the radius is proportional to m, because v is same, b is also same, q is also same, only the it is, in the sense, it is one electron and proton, so you can just neglect the sign. So I can say for the same charge, and magnetic field, for the same charge, velocity and magnetic field, for the same charge, same speed and magnetic field, I can say R is proportional to m. R is proportional to m. Now we know that you have to compare the mass of proton and mass of electron. Now radius is proportional to mass, and since we know the mass of electron is lesser than mass of proton, or MP, mass of proton, is greater than mass of electron, and hence the radius is smaller for electrons. The radius is smaller for electron because its mass is less. The radius is smaller for electron. Now take down another problem. Second problem. An electron is projected in uniform magnetic field parallel. First one is parallel, second one parallel, normal, parallel, normal, and the third one is at same angle, at some angle, sorry, at some angle, at some angle theta, you can say, to its direction. What will be the trajectory of electron in each case? Trajectory of electron in each case. Now here an electron is projected in uniform magnetic field. You are projecting an electron into a uniform magnetic field in three different ways. One is parallel to the magnetic field. The velocity is parallel to the magnetic field. Another one is normal. And the third one is at some angle to its direction. What will be the trajectory of electron in each case? So this we have already studied when we read about the theory part, that is when we read about like moving charges in a magnetic field, how it will move when the velocity makes different angles with respect to the magnetic field. Now when it is projected parallel, electron moves in a straight line. First one, that is the direction will not change when it is the velocity is parallel to the magnetic field. When projected parallel, electron moves in a straight line. Now when projected normal, electron moves in a circular path. And the third one, when projected at some angle, and some angle, electron follows a helical path. Helical path. Remember, projected parallel moves in a straight line. When it is projected normal, electrons move in a circular path, and when it is projected at some angle, electrons move in a helical path. Now that completes this problem. Now you can take down another one. Third one. An electron is moving along positive x-axis. An electron is moving along positive x-axis. Positive x-axis. In the presence of uniform magnetic field, along positive y-axis. Along positive y-axis. What is the direction of the force acting on it? Direction of force acting on it. Now see here, we are given with an electron and it moves in the positive x-axis, and then we have a magnetic field along the positive y-axis. Now what is the direction of the force acting on it? So we know whenever a moving charge enters a magnetic field, it experiences a force, and the magnitude of this force is given by F is Q VB sin theta, or I can write the force as Q into V cross B. Now given B is along the y-axis VI, and also given magnetic field B is along the y-axis J, unit vector J. Therefore F can be written as equal to Q into B into I cross B into J. So this will become equal to QVB into I cross J, and we know I cross J is K. That is why force is along Z direction. QVB into I cross J is K. Therefore I can say that force is along the positive Z direction. You can write the force is acting along the Z direction because it is unit vector K. Force is acting along the Z direction. The force is along the z direction.